Well, hello everyone. I'm Jack Balash with R4 Technologies, and I'll be hosting our webinar today. I'm really looking forward to this. And as people log in, just feel free and welcome, and we're excited to have you. I personally have been really looking forward to our conversation about mining operations and exploring how large, complex organizations like the U.S. Joint Command are using AI across all 5 branches to ensure that they're always ready and operating at capacity and addressing many of the same challenges that mining operations face every day. By way of setting an agenda, we'll lead this conversation off with this discussion off with a conversation between our panelists, and I'll introduce them here briefly. Then we'll turn this over to chat with the audience. So bring your questions, keep it lively, keep it interesting, and we'll post those in the chat, and we'll surface them up to the team as they arise. So looking forward to it. Today I'm joined by Mark Heinrich and Vitaliy Dubravan. Both have a long history of solving complex cross-enterprise issues using AI. And Mark and Vitaliy, if you could just take a few minutes, give us a little bit of your background and where you're coming from, and then really what you're working on today as well.
Mark, you want to start?
Hi, I'll start. Yeah, thanks a lot. Hey, I'm retired Admiral Mark Heinrich. I'm proud to be a member of the R4 team, and my background is a career logistician. I worked in the Navy for nearly 35 years in positions of increased duties and responsibilities, starting as a young officer on a destroyer, deploying across the Western Pacific and into the Persian Gulf, and then heading back the other way. And along the way, we went up into the Sea of Okhotsk and traveled to some very remote places, trying to keep my destroyer operating as a very young officer was a challenge. We actually had a fire on my ship and fought it for the better part of a day, and then had to limp into Guam for some repairs. I've served on a cruiser and aircraft carrier, and I've deployed to Kuwait for the better part of 2008, and I lived in the Philippines running a very large fuel operation that supplied most of the South China Sea, the 7th Fleet, and all the bases and places in the Philippines. So that's just a little bit of my background as a junior officer. And then as a senior officer, I was responsible for the operations of the Defense Logistics Agency, which is a $50 billion a year enterprise, supplying the services, all the services around the world. And then I worked in the Navy Supply Systems Command for the last 4 years as Chief of Supply, and I was responsible for literally hundreds of operations around the world that sustained our military in peace and war, and ran a very large contracting operation. Today, as part of R4, we actually have a team in Canada led by Mr. Tim Rashan that sustains and works in partnership with a number of organizations, the Nunavut's and many others who are very involved in the mining enterprises of Canada, doing environmental work and sustaining the things like the Mackenzie Valley Highway and others that are very important to the mining enterprise. I've traveled to Jordan with miners and traveled around the world to sustain some of the operations that we have today. Thanks.
Thanks. It's quite the background, Mark.
Yeah, it's impressive. Every time Mark describes his career, it's so fascinating. Yeah, my career is not that exciting. I started as a microelectronics engineer, and from hardware engineering went through software design patterns, and end up working and building large data warehouses and BI systems for Fortune 50 companies. And after all that, I joined the R4 team many years ago. Don't even remember how long ago it was. And we're trying to solve almost impossible problems here. We're trying to come up with the solutions, universal solutions that business are struggling with, and have a way to solve it elegantly at minimum costs without breaking the bank. Because sometimes your cost of your solution may exceed the cost of the losses you will inherit. We're trying to stay away from that type of business. And one of the latest challenges these days, you can imagine, is dealing with AI systems, because these guys just started eating bread and butter from a consulting world. And it's very, very interesting in the world we're living in, when you have to compete not with people, you compete with machines, and trying to predict where you can survive for the next several years, and knowing that what this system cannot do, that human brain can solve today. That's a very, very challenging task, but there is no time to sleep anymore.
Feel you there. That's well, thank you both, and we're excited to have you. I'm gonna, as I was getting ready for this, Mark, we were discussing a few weeks ago, mining has some very unique challenges. They're operating in extreme conditions, everywhere, like you kind of alluded to, from the Arctic to the deserts to the jungles, and where equipment, systems, processes, and parts failures can have serious consequences across an entire operation. Working in kind of those dynamic environments too, where environmental shifts. I think, Mark, you alluded to the Arctic and the highway there. One of the challenges they're facing is that as winter's warm, you have to adjust your planning of both your operations and your supply chain to accommodate for shorter opening of the roads. So definitely, kind of saw that complexity there. And this certainly carries over to the AI side too, right? Where organizations are often working with, Vitaliy, you were sharing how often they're working with, highly variable, messy, incomplete, difficult to normalize data. Mark, I'm curious, as we outline this, just how closely does that really align to what you saw when you were leading supply chain in the Navy?
Yeah, thanks for a great question, Jack. And operating in the far reaches like miners do, whether it's in South America or frankly in Arizona, the challenges are very much the same. And I've worked very closely with John Deere and with Caterpillar and many other companies who offer their we'll be there to help you sort of approach. But really it falls to the companies more often than not, to sustain their equipment and sustain their operations in a robust manner. I've traveled up to Fort McMurray in Canada, where the very large it's more of a mining operation than it is an oil field, but the oil sands of Canada require these huge trucks to scoop large pieces of sand out, put it in large trucks, and take it to what they call a refinery, but really it's just boiling the sands to get the tar sands out, and then the tailings have to be disposed of. It is much the same as a mine, and today in the North Arabian Sea, the Navy but more especially the Navy is really making up new ways to sustain itself, because it depended on bases inside the Persian Gulf that are no longer available to them. So they have three logistics ships that are doing a what I would call a racetrack from Diego Garcia, going up thousands of miles to meet them in the North Arabian Sea, and then coming back with retrograde material. What I've learned in that whole process is predictions and forecasts and having the wherewithal to be prepared is everything. And you can't carry everything to a mine. You can't anticipate every single thing, because that would be crazy. And you can't take everything on a submarine. You can't put everything on a carrier. Submarines have to be able to sustain themselves for extended periods of sea. They can't surface and they can't go back to port. And aircraft carriers in the North Arabian Gulf can't go into port because they have to be at sea. The Lincoln is absolutely breaking records. They have not had a port visit in 7.5 months. Since they left San Diego, they have not had a port call. So just like mining, you have to sustain your people, you have to sustain your equipment, and you have to make sure that that all the technology is absolutely doing what it has to do, and that's one of the things that I like R4. That's why I'm here, and getting into work with people like Vitaliy helps ensure that the predictions and the forecasts that you need to be successful are actionable and accurate.
Got it. So when you think about, even like you mentioned, like carrying supply or spare parts, right? And it's a huge cost for mining operations. You know, how it really feels like you're saying it's critical that you're able to predict with a high level of accuracy demand to be able to kind of offset that. How did you guys address that in the Navy, or how is the Navy addressing it today? Is maybe a better way to ask that question.
Well, it's a great question. We I was talking to a Navy man recently, and we were talking about submarines that deploy from Washington State in cold water, and submarines that deploy from Georgia in warm water. And I said, do you see a difference in the maintenance requirements for the two submarines, similar submarines, but deploying in different environments? And at first he said, well, no. And then he thought about it for a while, and he said, that's exactly right. So preparing for a mining operation is much the same as preparing for a ship deployment. It's not so simple as just, one guy gets a t-shirt and a pair of shorts because he's deploying to the South Seas, and the other guy gets a jacket and a knitty hat because he's deploying to the Arctic. It's much more important to that. What we find is that the companies that offer their promise that they'll be there for us, Lockheed for the Navy, and Boeing and Northrop Grumman and others, they're still using, frankly, note cards and legal pads, much as the services did, way back in World War II. So their thinking and their ability to have spares for us has been, I'd say I'd give them an average grade. I don't give them a failing grade, but I give them an average grade. Mining and the military need absolutely excellent support. So we prepare. We look at what we've done in the past, but don't just look at supply data and say, look, we had, 4 demands in 2 years, so therefore we're going to take 2 for the coming year because that's the average. We look at whether the equipment's going to be operating in a more intensive environment. We look at what normally fails in high heat, and preparing for that is how you do it in the services. And airplanes operating in the high heat of the summertime, the canopies get swept by sand. In fact, that's one of the things that they're going through quickly is canopies on their frontline jet fighters. They need more of them than they can get, and it's actually a problem for them. And the same with things that would be impacted by dust and dirt and the sandy environment of the Middle East.
So Vitaliy,
Jack, if I may add a bit more on the forecast part. First of all, when we talk about forecasts, there is no forecast that is 100% accurate. People have to take that into account. We as human beings, we assume that it's either black or white. There's nothing like this in nature. So it's some probability. And you can only say, increase probability of correct forecasting, not make it ideal. No one guarantees it. That's one problem we're dealing with all the time. And there are different mathematical methods used to increase probability in a particular situation. What works in other situation may not work in the other one. And that's what the data scientists are coming into play. That's what our automation that we provide kicks in when it's based on data science experience and what typical scenarios are used in such cases, what type of approach to take. It's not randomly picking some new data science algorithm that you just learned and trying to use it. So that's one side of the story. The other one is data availability. When you talk about extreme conditions, usually data flows with a delay. It may be delayed for several days, because of the weekend. It may be data is not available for the week because the satellite link is broken. And you have no idea in the headquarters what's happening in the field. So you have to make predictions for missing data and try to compensate for that. And that's essential part of the predictions algorithm, because without it, any system will stop operating immediately. Data is delayed. We work with different branches of military, and some branches simply do not give you data on the weekend, no matter how hard you ask. And then not just weekend, Monday, you will get data by the end of the day only. So you're practically operating on 4 days of data, but they will give you maybe for the weekend data later, maybe not. So it's random. It's sometimes look like a lottery. So that's the reality. You have to take that into account. The world is not perfect. But
So
you
how
were
do
going to
you,
ask something else.
well, no, I think you really answered my question. It was, I think the one question I'd have kind of as follow-up is, when you have that, the sporadic nature of data being contributed to a model, how do you think about building, kind of future-proofing against that or adjusting for it?
So there are several methods you can use. In this case, you can try to predict what will be the next data element. That's if you have any repeatable patterns in the data, you may try to use that technique. You may try to skip it and say, yes, I know that there's a problem. Let me know that this is a pattern. Just ignore the gap and try to glue data elements together to predict that next time after the next gap, that's what I expect. So it all depends on the nature of the data we're iterating with and what's expected as delivery, a result of delivery. If we need to provide any type of maintenance schedule for expensive equipment, we'd rather have high probability that we have to maintain that equipment. Otherwise, the cost of wrongdoing may be significant. So we will maybe try to run more cycles of simulation and see, is there anything that will tell us that something may go wrong in our predictions? Sometimes it's moving at the speed of light and you have to really generate too many predictions too fast. But then the big numbers are coming into play, and then your overall recommendations may be good enough because each individual recommendation may not be good, but aggregate of their recommendations will be way more accurate. That's what's happening there.
Very interesting.
Yeah,
Okay.
I have a follow-up, Vitaliy. One of the things you've taught me is that a lot of people think they have to spend a bunch of time, purifying their data and figuring out what's wrong and figuring out what, the missing gaps. And one of the things I think you've taught me is that good AI systems like ours, you can account for lumpy data or missing data or maybe even wrong data sometimes.
Yeah, maybe
That's
Mark, that's
a
a good.
very good point because what's happening there. So one more note there. If you're trying to purify data and do any type of data cleansing, you may lose some important patterns because you may say, oh, that's an extreme. No, that's a signal. You have to look at different angles at the same data set, and for different algorithms, it may tell you very different story what you're looking at.
So you're hitting an interesting point there. You're talking about really not stripping out your signal by over normalizing. Is that what I'm understanding?
Yep.
Perfect. Maybe, Mark, I put up kind of the scope of our project that we did with the Joint Command across all the different weapon systems. Over the next few minutes, maybe want to walk through kind of what we did. I sort of started with the state of the data, and kind of start there, and then kind of talk through what we were solving once we had this data set.
Yeah, you bet. So the goal was to help predict the readiness to predict the readiness of our operational systems so that schedulers would have a better confidence that if they schedule an aircraft for a mission, it would be available to them. That was the goal. And prior to that, the schedulers literally had very little confidence that when they scheduled a certain aircraft for a mission, it would be available. They all walked in the next morning crossing their fingers that airplane was going to be, quote, up. And and so what the R4 team started to do is digest as much information as they could, and information about maintenance, information about supply, information about operations, and then even go further. What's the mission profile look like? And then they added in weather, which was really interesting. And so just I can prattle on for a while about this, but what you got out of that was you started to get very successful predictions on what aircraft would be up and what aircraft would be potentially be down. And I yeah I love your comment about the thousands of assets, thousands of millions of parts on this, the fog of signals. It's really important. I can give you lots of examples. H-60 helicopters as an example.
Yeah.
Um, H-60 helicopters are flown by the Army, the Navy, the Air Force, the Marine Corps, the Coast
Hmm.
Guard. Everybody flies them, and yet the way they manage the data is completely different. A young man flying his helicopter off of a Coast Guard cutter might have similar issues to a young man or a woman flying his aircraft off of an aircraft carrier,
Hmm.
but the data is captured differently, and so trying to make you know uh, clarity on why that's different, but why it's the same is really important to us these days. So
Mhm.
that's how you create synergy and how you create, inter-service collaboration, and companies like R4 help do that.
It's interesting you bring up, one piece of equipment being treated differently. There's similarity too in mining, right? You may have optimized each of your individual facilities, but kind of there's still an opportunity to optimize across the whole entire organization and treat it as more of a holistic solution. I think that's really what I saw with what you guys did with the military. Do you have any thoughts on that?
Oh, sure. Yeah,
Yeah.
in fact, so you have these very large operations, and I go back. I'm not dunking on Caterpillar or Deere or anybody like that, but I'm offering a perspective. So many companies promise that they will be there for you, and and the predictions will, Lockheed Martin, as an example, that is now bought Sikorsky and is responsible for the H-60s, will raise their hand and said, I could, the old joke, I can name that tune in 5 notes, kind of thing. They will promise that they can be there to sustain you, but what you find, at least we did in the military when I was there, is that only the government and has the wherewithal to have the appropriate investment in spares, and and uh and
Mhm.
companies like Lockheed and others, were they had a finite budget, and they couldn't account for everything, but they often didn't guess correctly about what the requirements would be. So Boeing was had a similar situation with their commercial jetliners, Boeing sold a product called Gold as an example. They said, we will predict your requirements and we will be there for you. They have literally only one requirement, one example of when they sold Gold and it worked for a customer. And it was Singapore Air was flying from Singapore to Moscow, and on the way, the airplane said, "I my APU has gone down." And Boeing's looked and they said, "Oh, I have an APU." Problem is, it was in Heathrow, so they loaded up the APU, and they got some employees, some artisans, some technicians that could do it, and they flew it. They flew the APU and the people to Moscow. And when the Singapore Airlines airplane landed, the pilot said, "Hey, my APU's crapped out," and they said, "Aren't you glad you have Gold? Because we're here for you." That is the only time that has ever worked, and they finally sort of discarded it. And so that's great, but if you're in the far north in Fort McMurray, or in the far south in one of the Freeport McMoran um, mines in South America or in the middle of Australia, you really have to take care of yourself. That's for sure. That's my opinion.
So own your forecast is
Own your,
your
that's right.
message.
Own your forecast. Darn
Okay.
it.
I like that. The
Yeah.
and I think the other highlight another issue here, right, is that systems and equipment are interdependent. So it's not just that one piece goes down and maybe you're good, maybe the vendor's good on that one particular piece, but are you able to see the downstream and upstream impacts from staffing, resources to, just reduced production? That's much harder to predict than just, hey, my tractor's down, right?
Right, right. Yeah, and in the case of an aircraft carrier, look, you can turn on CNN on any given day, and you can find out that the Abraham Lincoln or the Bush is launching a mission that they probably didn't know they were going to have 2 days ago. So you have to be ready. Same with mining. You've got to be ready, and you've got varying weather and all the other things that impact the environmentals, and of course the mission itself. What you're mining for, and what you got to do.
Interesting. Okay. Well, maybe talk us through a little bit. I mean, we had pretty good results here with the military. Would you mind kind of walking through these for us?
Sure. Yeah. So the piece that's most interesting is the schedulers were working really to schedule 2, 3, 4 days out. That's what the schedulers needed. Now the fact that they had 96% accuracy within 4 days is really
Hmm.
exciting, and the fact that it just continued unabated with very high accuracy for those first that basically they could look 4 days out and see that with very high confidence, and that continued very steadily. That gave confidence to the schedulers. It gave confidence to the air crews too, that their airplane would
Yeah.
be up, and they didn't just make some broad brush and say we're going to have you're going to have 18 and a half, although it sounds ridiculous, 18 and a half airplanes out of 20. They said you're going to have 19 out of 20, and this is the airplane that's probably going to be down because it hasn't been flown in a while, or the last time it, 3 times ago it was down for a specific gripe that is continuing to occur. On When I was on my aircraft carrier, we had an airplane that had a generator fire, and that caused electrical faults that continued unabated. And so the schedulers were scared to schedule it because they said, "Oh gosh, with these electrical faults in this airplane, we're kind of the opinion that the chances of it launching successfully are relatively low." So that was the perfect example of people sort of back of the envelope, just writing it on the envelope and figuring it out. That's probably probability low, but we need to be able to do better than that because you got to predict parts and requirements and people and everything else, especially in a mining environment.
Yeah, no, it's interesting. And so like, really what you're saying here is that it's being able to say not only this is the equipment, but what you're doing is reducing like the need to shuffle equipment or ship stuff in. If we can say 4 days out, this has the ability to operate within the window we expect, right? So that's a
Yeah,
huge logistical solve as well, I would imagine, for the military.
right, exactly.
Interesting. All
Yeah,
right.
yeah,
Um, I'm going to kind of, before we position shift to kind of Q&A, I just want to kind of summarize sort of what we saw and what we heard. It feels like both sectors, you're operating with unpredictable environments, high cost equipment, significant downtime risks, and really in a world of vast unstructured data. And both need to find ways to take advantage of that data to minimize equipment downtime and optimize lifespan, reduce cost, and make sure that you're allocating your assets the best way possible, whether that's spare parts or just capital assets in general. Um, and then just that, I think the part we've touched on, and really I think you see with the military, is that need to be able to coordinate cross branch, cross functionally. That silos really can't exist if you're going to respond holistically. And it feels like mining is very much the same, right? You need the supply chain, the maintenance organization, purchasing team all aligned and driving towards us off those same signals to be effective. And that's really how we're creating that predictive environment. And that at the end of the day, it really is all about yield, right? Whether it's yield on the military asset, or are we getting the most out of that mining operation that day, that year, especially when prices are high or prices are low. So feels very similar. And with that, I'll kind of pause. Anything, Vitaliy, you'd add, kind of having listened to all of us?
Yeah, no, you're absolutely right. Comparing these two extreme scenarios, it's probably for the mining industry the only piece I will add. Military operate without boundaries, but mining operations are within country limits. And if I have to get a part from another country, then I have to go through customs to do custom clearance. And sometimes company create their warehouses right before customs terminal, so they have their part before clearance. And if they need to ship to another country, they will put it back on the plane, fly to the next place, or the place where it probably will be consumed, and then do custom clearance in that place. So that adds extra time to the operation, but at least that will speed up the process in many cases. The military does not deal with that. They have the part, they will fly whatever it needs to go.
Yeah, well, I'm going to tell you a funny story, Vitaliy,
Okay.
because when we were on my aircraft carrier in Bahrain, on my aircraft carrier, excuse me, we had our daily daily airplane that flew the parts out from Bahrain to the ship. What we had to do was the airplane from the United States would land generally about 10 o'clock at night. And if we did nothing, the parts that were on that airplane would go to the customs house, and then we could get them out when they opened at about 10 or 11. There's a little bit of this, what time are they coming to work sort of thing. But we had to have that part on our airplane at 7 in the morning in order to make our morning launches, especially if that part was critical to fixing an aircraft that just needed that one part. So our supply team stood by the customs office when the airplane landed, and they had a list of parts, and they had given the customs officers ball caps and lighters and belt buckles and every manner of thing from the aircraft carrier, patches and things. So they were very proud to help us. And so they would look at a part as the part would go by, and they'd go, "I need that one, and I need that one," and the customs guys would say, "Go ahead, take it." And so other than that, having built a relationship with the customs officers, if that part got on the morning flight to the aircraft carrier and the maintenance crew was standing by, that aircraft could make the morning launch. And the pride we felt when that happened was boundless. And of course, the air wing was always very proud of the fact that we could pull that off. And we ingratiated ourselves to them by doing things like that. So if we needed a little bit of extra log support or something, but my point is everybody, whether you're a miner or you're a military guy, has to deal with customs headaches, and they're there all the time. It's just unfortunate.
It's got to get the forecast right.
Got to get the forecast right.
So I got a question here, guys. The question is, how predictive is environmental data when forecasting spare parts needs? Any thoughts on that from either of you?
Okay. I'll let maybe Vitaliy go first, because what I'd like to hear Vitaliy talk about is how putting environmental data into a forecast can help.
So this simple scenario, even coming from a non-military, non-mining business, in regular retail business, if you deal with situation with a drought, and you have with consumers, you have to ship a lot of water to local warehouses. But if it's further north, they don't need water. They have completely different needs. They may need blankets because they want to keep themselves warm. So you have to take into account weather patterns. You need to take into account any storms coming in your area. And that may also delay flight with the part that you're waiting for. Logistics, that contested logistics world, when some routes may not be available. We're seeing that right now in the Red Sea, that some routes are blocked and people going around, and all the shipments were delayed significantly. You have to go around Africa to get to the destination. So you have to consider different factors. It's some of them environmental. Another environmental factor, remember this volcano in Ireland many
Yeah,
years ago that clogged the airspace above it?
yeah.
So that's another factor. It's all happening. That's the environment. That's the reality we deal with. It will impact logistics. It will impact consumption. It will impact usage patterns, and that's happening absolutely everywhere, no matter where you go.
Got it. So really understanding the operating environment and anticipating the issues for sure.
Mhm.
Okay. Let's see here. What else do we have here? Here's one for you, Vitaliy. What are the biggest challenges in normalizing data when the parts and inputs themselves keep changing?
So that's an interesting one because, first of all, our preference when we talk about data, uh, we don't normalize data. But if the different parts produce different scale of inputs, then you have to somehow compare A's to B's, and you have to be able to adjust the signals. If possible, again, try to use as much volume from the equal type of equipment as is individual input. Don't blend equipment together. Even though there's a new type of part, don't try to translate one into another. It's just new input, new data coming in. If there is a reliable way of converting one into another, yes, you can normalize it. But we have to be absolutely careful because what I mentioned before, you may throw baby with the water and you may lose some important patterns because normalization usually does this. It's trying to optimize and auto scale the measurements coming from the equipment, and that may cause massive problems.
So you'd advocate being able to, like we do, right? Process data without normalizing it to be able
You
to.
have to train the model within certain ranges, and then if
Interesting.
ranges are changing, it better have to retrain the model in many situations versus trying to say, oh, let's have fixed algorithm for data normalization. It's dangerous.
Got it. Okay. No, that's really cool. Um, Mark, here's one for you. What advice would you give supply chain teams using AI, given your experience with the Navy?
I I have lots. The number one thing is don't AI. It's oh, should I do it? Should I try it? What am I going to do? It's going to cost me $1 and might not get my return. I'd say own it. I get out there and try it, and I it sounds a little self-serving, and I don't mean it that way, but I see a number of people back not too many months back where they said, maybe I can build it myself, and I'll do an auto hobby shop sort of kind of shade tree mechanic thing, and I'm going to take a a seminar, and then I'm going to try to make my own AI system. That and maybe with agentic AI you might feel confident you can try it, but I would say one of the things we've learned and we've seen the Navy and literally all the services try to do things with AI on their own, and it's I don't know if it's because they're scared of picking a vendor, or they believe they can do it themselves, or they're worried about the cost. There's 100 different reasons why people jump in or why they don't. But I would say find a company that's reputable and do your due diligence. Have confidence that that company can address the challenge you have, and then jump in. Be a demanding customer for sure, but sitting on the sidelines, while you continue to be criticized because your forecasts are poor. I do see that right now, and I see it in the Navy, frankly. The Navy has continued to be not they don't wring their hands or anything like that, but they do worry that I'm spending my money unwisely, and yet they continue to proclaim that the biggest challenge is accurate forecasts. And that's not just the Navy, being fair. That's really everybody. So I would say be a demanding customer, learn as much as you can. Um, and that's what I've learned. That's what I've learned from my time in the Navy. We would have given almost anything to have a better forecast. The Defense Logistics Agency, one of the things that they have is they also have forecasting issues, but they also carry a very, very large inventory. And what they found is as their inventory approached $1 trillion, the guys from the Senate Armed Services Committee would say to them, you guys, you are going to have to appear before us if your inventory gets the north side of, say, $1 trillion, because the public, generally, the public who pays taxes wants to believe that their money that they're paying in taxes is going to go towards the readiness of our frontline aircraft, the H-60s and the others. And to hear that there's a bunch of material that's not selling, that's sitting on the shelf, that bothers us. So that's a perfect example of where if you do a forecast poorly and you make an investment where you shouldn't, there's real risk. And so what does the military do is they do disposals. If they have 12, they'll sort of go, I've used 4 in the past several years. Maybe I made a mistake, and I'll keep 4 and I'll dispose of 8, or something like that. And what they find out is that part was a critical component that only gets used every 8 years or every 10 years, because that's when the aircraft gets overhauled. Or it's a jet engine. When the jet engine gets overhauled, there's specialized parts for a jet engine overhaul. But that was a kit. And so I would say do your homework, be willing to roll up your sleeves, work alongside your partners, your commercial customers, but jump in.
Okay. All right. Let's see. It looks like all the questions we've got for today, and I know we're approaching time. So I just want to say thanks to everybody for joining us. Mark and Vitaliy, I really appreciate you guys sharing your insights, and we're all available on LinkedIn if you'd like to connect and have questions we can answer, and just be resource if we can and when it makes sense. So thanks again, everyone, for joining. And
Well,
go ahead,
I
Mark.
do want to highlight one of our guests, and that's Lou Martinet, who I know is the father of the Navy pilot who picked up the Artemis astronauts when they landed in the Pacific not long ago. So I see Lou Martinet in the audience, and I wanted to laud him. He's a great guy. He is a master educator, and just a tremendous to have him on the line.
Well, thank you for joining us, Lou. Appreciate your service.
Yeah.
Take care, everyone, and thanks for the time today.
All right. See you later.
See you guys.
Bye now.
Thank you guys.